Hello everyone, and this is lesson 3 in the Introduction to Houdini series. Now in the previous lesson we saw the basics of procedural modeling and how you can use groups to sort of make a better procedural system. In this lesson we're going to take a look at another very important concept which is called attributes. And we're going to combine attributes with the copy tool, and I'll give you an idea of how you can use those two things in combination to create more interesting stuff. So what I'll do is we'll start off with the basic copy tool because we saw a bit of it towards the end of the previous lesson. So I'll first look at the basic copy tool and then we'll carry forward from there. So I'll just create a piece of geometry and let's go in, and I'll create a box. Now you do get multiple variants of the copy tool. So you have, if you type copy, then you get something basic called copy and transform. And then you also get something called copy stamp. Now between these two are almost similar, except the copy stamp has a few more options. You'll see that they both look, pretty similar. So usually I would suggest using the copy stamp instead of using the copy tool because they'll both give you more or less, similar options. And then you have a few more things, like you have something called as copy to points, which is what we had used last time. We'll be using this a fair bit. It's a simplified version of the copy stamp tool, but it is equally powerful. And yeah, that's primarily it. So those are the three main things. You have something new called copy to curves, but we'll take a look at that later. Okay, so where do we start? So I'll start off with just the basic, copy stamp, and it has two inputs. The left input is for copying, and the right input is if you want to copy it onto another geometry. So we'll worry about that later. First, we'll just make a simple copy. Okay, so I'm going to take this box and I'll just make it slightly flat and I'll connect it to this. And then it's pretty simple, right? So you can just come in here and I can make a copy, and then you can increase the number of copies, and that's pretty much it. Like, it's not overly complicated or anything. You can also rotate it, so each one, it's like a cumulative effect. You can also sort of scale it down, so each one scales down progressively. We can slightly move it up. So if you want to do something like steps, you can do steps. Like, I can come back to the box and probably just adjust the size of it, and then come to the copy. We'll take it up and I'll move it close by. So there you go. See, so you can have steps. So it's pretty simple. Like, this isn't anything, overly complex or whatever. What you can also do, which is pretty interesting with this, is that you can also convert the number of copies into groups. Okay, so if you switch on this button, which says create output groups, then if you middle click or if you click on the eye, which is for information, you'll see that it has converted each object into its own group. And it doesn't need to be a single object. It can actually be like, multiple objects. It will just convert each copy into its own group. So if you want to later on modify or manipulate that group independently, you can still do that. So just to do something very sort of quick and simple with this, let's make something like a spiral staircase. So I'm going to get rid of this, and let's take this box and I want to push it to the side. Okay, so like we had done before, I'll take a transform and I want to push it to the side in the x-axis. We'll just call it move to x. Okay, and we'll do it like we've done last time. So I'll take the size x, I'll do a copy parameter. I'll come in here to translate x and do paste relative reference and divide it by 2. So you have this. Now along with this, what I also want to do is let's just give it like a stand on the side, like a railing. Okay, and then what I can do is I can just take a line and let's just manually place this. Okay, so we'll just take this, I'll take a transform here and I'll just place it here. Now if you want to give the line a thickness, you get a very simple option called polywire, which is essentially for giving thickness to curves. So you can just connect this and you'll see that it gives thickness, and we can just lower it, and you can increase number of divisions. So let's make it 20. Okay. And maybe just increase the height a little bit. So we have these two things, then I can just merge them together. And we can call it step. Okay, and then we can press L just to organize it. Now let's do one more thing, which is I don't want it exactly at 0. I want to push it a little further out. So I'll just take a transform after this and just move it a little bit. Okay, so this is good. And maybe this also I can move it, slightly ahead over here. Okay, so this is nice. So now all I can do is I can take a copy tool. So I can take a copy stamp and plug this in. And what I want to do is I just want to rotate it by say 20 degrees and move it up by some value. And then we can just increase the number of copies, and there you go. Now, if you want, like the steps are currently intersecting, right? So if you want the steps to be like, they should exactly touch, the top step, then what we can do is I can take the height of this, so which is 0.25. I can right click this, do copy parameter, and come into my copy to the translate Y and do paste relative reference. So what that does is, whatever is the height of the box is how much, this thing will move. We can also do the same thing for the transform here. Okay, like right now, I believe the line might be sort of, slightly intersecting in there. So we can do the same thing. So I can just take this guy, which is kind of moving up. Okay, and I can just take this and I can do right click, copy parameter, come into transform and do paste relative reference. But you'll have to divide it by 2 because the box is sort of halfway through. So we'll do divide it by 2 and see. So now what happens is if I adjust the height of the box, you'll see the steps adjust accordingly, and even the railing on the side or the bar on the side also sticks to that. So a little bit of basic channel referencing goes a pretty long way. Okay, as a final thing, within this, you do get 2 functions within the copy tool, okay, which allow you to access the copy number and the total number of copies. If you click on the help, and it'll open up the help for copy stamp, and if you click on inputs, then you'll notice that it says something here called copy specific variables. And you get, like, we're not going to do all of them. Okay, but it can pick up a lot of stuff. But there are 2 which for now are important to us, which is CY and NCY. Okay, so NCY is number of copies. So what I want to do, let's say, is that no matter what I do, I want the number of copies to fit within say 180 degrees. Okay, so what I can do here is I can just take the rotate and I can say whatever is, like, we want to rotate within, let's do 360 for now. Okay, so we want to do 360 divided by the number of copies is how much it should rotate, right? So the number of copies is 18. So we're going to do 360 divided by 18, and that will give me the exact amount and it will fit it within, 360. So if I just take this and I do 360 divided by, and the function is NCY, and you type it in with a dollar. Okay, so do a dollar sign and all capital, do $NCY and press enter. And now what's going to happen is, see, as it adjusts, if I come to the top view, you'll notice that it always stays in a circle. No matter how many copies you have, it will always stay in a circle. If I wanted half a circle, I can make this 180. So now it will always be half. Okay, like, it's no matter how many I increase, see, the height keeps increasing, but like if you look at it from the top, it's always like a semicircle. So yeah, so if I want to make it 90, of course, like 90 is a little, it's too less. But the point being, like, a little bit of channel referencing and a little bit of math allows you to build, far more complex stuff. Like otherwise, if you're going to build a spiral staircase like this, and if you make changes, you have to every time go back and, readjust the number of degrees or the height, and all of those things. Here, because we just connected two simple functions in there, you can easily build a much more break-proof system. So that's basically the copy tool. Okay, now let's move on to the more important thing, which is attributes. So I wanted to introduce the copy tool so that when we go to attributes, it's easier for you to understand what is going on. All right, so let's talk about attributes. So what exactly is an attribute? To keep it very, very simple, an attribute is a value. That's it. Like, it's a value that is stored on either your points or your primitives or vertices. Okay, and you can use that value to modify or drive parameters, right? Like, that's basically it. And attributes can be generated in like an n number of ways. You can create your own attributes. There are some ready-made attributes that Houdini gives you that you can use. Or even you can have stuff like, when you do simulations, even those can generate attributes. Now, there are multiple types of attributes. We're going to take a look at 3 of them. So you have 3 types of basic attributes. The first one is a float. So a float attribute is a single value in decimal places. Okay, so anything like say 1.01 or 5.06 or 0.0008, like any of these can be a float attribute. So essentially, when do you need a float attribute? Like, if you want to create an attribute that will affect, say, a bend angle, then you need a float attribute because a bend angle is a single value. Okay, so that's a float attribute. Then the second thing you get is called a vector attribute. So vector attribute is 3 values. So usually something like, XYZ is a vector, RGB is a vector. So now within this, what this effectively is like 3 floats make a vector. So in this case, just R on its own is a float, or just like Z on its own is a float. But all 3 together form a vector. And then the last one we'll take a look at is called an integer, which is essentially a value, but it has no decimal places. So like 1, 2, 3, 4. So where you can use something like this is, let's say if you want to generate an attribute value that will affect, say, the segments of a sphere. So the segments of a sphere don't have decimal places, right? It's like 1, 2, 3, 4. So that's where an integer attribute comes in. Now the second point is, how do you create them? Okay, so there is a node called attribute create, but there is also a way to create it using basic coding. Okay, so just to look at the basic coding way is, every attribute starts with an @ sign. Okay, so, and you can give it any name that you want. So if we say @hello, and then before that you need to define what type of an attribute it is. Okay, so if it's a float attribute, you type an F. So this will become a float attribute. If you want a vector attribute, you type a V. So it will be V @hello. And if you want an integer, then you do I @hello. Okay, that does not look like an @ sign, but this is basically it. Now, along with this, you also have some inbuilt ready-made attributes. Like when we did the groups thing, I did a p.x. Okay, so p is an existing attribute. Okay, so it's an @p, which is for position. And position is a vector because it is x, y, and z. But when we were doing p.x, that was a float because we were just taking one value, out of the position. Okay, so the first question that comes up is, how do you create your own attributes? Okay, so we've seen this, now let's see it in Houdini. Okay, and then I'll also give you a list of where, or where you can find all, the basic default attributes that Houdini, has. So if I create a simple grid and I want to create an attribute for this called hello. Okay, so the simplest way is you get something called as an attribute create. Because if you type attribute, you'll get a huge long list, and we want to look for attribute create. So take an attribute create, and it has a bunch of options in there. The first one is the name of the attribute. So we'll say the name of the attribute is hello. And then what is the class? So is this going to be on points or is it going to be on primitives? Okay, so we're going to say this is going to be on points. And then what is the type? So as I said, like you have more, but as I said, like we have float, integer, vector. Those are the three we are going to deal with. So I want it to be a float. Fine. And then is there a value to it? So I'll say the value is 0.2. Now you've created this. How do you see it? So if you come to the grid and you click on I, you'll notice that the default, because you have position, you will get to see your position attribute, which it says is 3 floats. So it's technically a vector. When I come to the attribute create and I click on the information, you'll see you have a new attribute called hello, and that is a float. So pretty simple. Now the question is, how do I see it? Like, is there a way to see this in the viewport? So there are 2 ways to see this. One is you can see it in the viewport, and another is you get something called as a geometry spreadsheet, which will give you, a breakdown of your geometry, and you can see attributes there as well. So first let's see it in the viewport. So I can just select this and I can press X, and X gives you what is called as a visualize node. You can also take it manually. So you can take a visualize node, but X is a nice enough shortcut. And default it is showing you the position. Okay, because if you come down here to visualizers, the default is kept to position. Now, if you want to see it, it's showing it to you as color, but if you just want to see it as a marker, that means it will show you text data. And then if you come in close, you'll see that, each one of these has like a text. So you have different ways to see it. This doesn't really help us. So I can just see it as text. So you'll see like this is essentially, it's nothing but the point position. Like what you're seeing here is essentially just the point position. But what I want to see is I want to see hello. So I can just take this and type in hello. And you'll see you'll just see 0.2 everywhere. That's what you've generated. You've generated a value of 0.2. Now, what can I do with this? Okay, because that's the question, right? What can you do with this? So let's say I want to use this to control my copies. So let me get rid of this. I don't want to see that. Now within the copy tool, there is a second input which allows you to bring in, any other, you want to copy a box onto a grid, then the grid comes in on the right side and the box goes in on the left. Okay, so I'm just going to take a copy stamp again, and I'll create another box. And what I want to do is I want the box here and I want the grid there. And what's going to happen is, see, it copied the box on the grid. Now what I want to do is I want to affect the uniform scale using the hello attribute. Okay, so I can just take the transform cumulative, I can turn it off, because otherwise it doesn't really have much of an effect. And all you do is you just type in @hello, and there you go. So what happened is this was a value of 0.2, it scaled down to 0.2. And you can notice as I start to increase this. So yeah, so as I increase this, you can see you're adjusting this. I can create, as many attributes as I want. So what I can also do is, let's say, now let's create an attribute using another way. So you can get something called as a wrangle node, which is essentially just, when you type wrangle, you'll get multiple of them. Just take attribute wrangle. Okay, don't need to take anything else. These are actually the same thing. The point wrangle, primitive, and vertex is the same, with just the drop down list change. So you can just take the attribute wrangle. Okay, so take the attribute wrangle, and we want it to currently affect points. And let's say I want to create an attribute which can affect say rotation in Y. Okay, so let's do that. So I can take this and I can just say F at RT, whatever you want to call it. And let's say this is a value of 35 degrees. And then since you're typing in code, if you've never typed code, it always has to end with a semicolon. Okay, so no matter what you do, your line always has to end with a semicolon. And then you click outside. Now nothing is going to happen, but if you'll click here and go to I, you'll notice that we now have another attribute called RT. As I said, there is another way to see these values. What you can do is you can split the pane top bottom. Okay, so you can do the Alt and right bracket key and right click on the scene view, and you will get something called as a geometry spreadsheet. So just come to inspectors and you will find geometry spreadsheet. And you can see, those are the two things that we have created. So we have hello and we have RT. Okay. So pretty simple. And so I can come down here and you can close this. And let's say I want to rotate it in the y-axis. So I can just type in at RT and there you go. So you're now rotating it in the y-axis. Okay, now the problem here is that default doesn't really rotate in the y-axis because the grid has normals and it causes an issue. So one of the ways to repair this, and this is just a small trick, is if you don't want to see your geometry, if you want to get rid of, it's spinning it in the wrong direction. The simplest way is there is a node called add. And what that will do is once the geometry disappears, the rotation sort of goes back to normal. Okay, so you can just take an add and I can say delete geometry but keep points. And so you'll just have the points left. And there you go. Now it's proper. Like if I bypass this, you'll see that it rotates in the Z and otherwise it rotates in the Y. So usually you want to do this. Okay, just get rid of the geometry and keep the points. It's fine. Yeah, so this is how you can create simple attributes. Now, along with this, Houdini also gives you like a whole bunch of sort of ready-made attributes. And one of the really common attributes that you have, which allow you to control copies, is something called as p-scale. Okay, so if you type in at p-scale, this is a float value. And all it does is it controls the size of your copies. It can also affect the size of particles, but we're not getting into particles as yet, but it can do that. And if a copy tool finds that there is a p-scale existing, you don't need to type anything in uniform scale. It will automatically just use the p-scale. Okay, so if I delete this channel and bring this back to 1, and all I have to do is I can come into the attribute triangle, and you can create multiple attributes here. There's no limitation there. So all I can do is for the ready-made attributes, like the ones that exist inside Houdini, and p-scale is one of them, you don't need to type the F or the V at the beginning. Okay, so I can just I can directly just type at p-scale and that will be fine. So if I do at p-scale is equal to 0, and you will notice that immediately everything disappears, because what it did is it scaled everything down to 0, simple. So if I take this and if I make it 0.6, you'll notice that, so you don't need to type anything in copy. Okay, if the p-scale value exists, it is automatically just going to use that for scaling. You don't need to do anything else. Alright, so this is the absolute basics of attributes. Now let's take a look at how to do something more complex. Alright, so firstly, let's take a look at how you can find out, the various attributes that exist. So one of the simple way to do it is if you type in VOP, like VOP, and take the second one called attribute VOP. Now attribute VOP is essentially a way to do node-based programming, but we're not going to do that right now. What you can do is if you go inside this node, you'll get something called as geometry VOP globals. And whatever is written here is how you need to write your attribute name. So these are the ready-made attributes that Houdini gives you. Each one of these things is an attribute. So P is position, V is velocity, then you get force, CD is color, and we will be using color. And when you keep your mouse on it, it shows you what it is. So P is a vector. And then like it's dark green and the light green stuff is a float. So CD is also a vector. The blue stuff is an integer. Okay, so you get something called point number. So a point number is essentially like if you switch on this, these are point numbers. Okay, so you can even use these guys to modify things. So you have point numbers, you have primitive numbers, you have vertex numbers, you know, all of that stuff. So what I can do is, let's say that, you know, right now we have single uniform scale. Now let's say if I want something like, I want the scaling to be equal to the point number, which is going to go, you know, stupidly high. But let's say if you want to do something like that. So essentially what that means is that point number 0 will scale to 0, and then point number 1 will scale to 1, and then point number 2 will scale to 2, you know, something like that. So what I can do is I can just take this and I can say at ptnum, which is the point number. And now if you come to the copy, you'll notice that it gets really big. But let's do one thing. Let's divide it by a fairly big number. So we'll say divided by 100. Yeah, okay. I think that was a little, okay. 100 is too much. Let's try divided by 10. Okay. 40. Yeah, see. So what you're doing essentially is you're just sort of scaling it down accordingly. Now, the problem is that point number is an integer and it needs to be converted to a float for this to fully work. So what you can do is pretty simple. You just type in a float before it. Okay, so just take float and put this in a bracket. So what that does is that it makes this into a float. And so what you're doing is now it will give you a better result. Okay, so that's why it was causing problems, because it's an integer and when you divide it by 40, it just wasn't giving you the result that you want. So we can do stuff like this. Now you can start doing some interesting things with this. Okay, because as I said, like the whole deal with building a procedural system is how much access that does Houdini give you, or does the software give you, that you can manipulate, you know, all kinds of data. So Houdini gives you a very nice little thing here, which is called as a sort node, S-O-R-T. So what a sort node does is it allows you to essentially change the point numbers. Now you might not think that's very useful, but when you start using point numbers to affect scaling, it suddenly becomes very useful. So if I take a sort node and I drop it in before my attribute wrangle, because this is where I'm accessing point numbers. And let's look at our copy. So what you can do is if I take the sort and I say change the order to the x-axis, see, now suddenly your scaling happens this way. If I say make it random, then your scaling happens that way. And I can do the same thing here. So I was using, you know, I was using this for rotation. What I can do is I can just take this and I can put a ptnum here as well. So I can do at ptnum and suddenly your rotation goes like that. Because since what's happened is like, you're not doing random rotation. You're just randomizing the point order. So since the point order is randomized, the rotation is essentially randomized. Okay, which is not exactly what is going on, because if I take the sort and I bring it back to like x-axis, you'll see like this is how the rotation is actually happening. But if I make it like, if I reverse it, then it can go this way. I can make it random. I can also shift it. Okay, so I can take a shift and just, you can see it shifts. Okay, and then here you get a couple of more interesting attributes, which is if I go into the warp, and I can take anything, let's take a point warp. And you have something here called time and frame. Okay, and time and frame basically are allowing you to access the frame number or the time number. Okay, so if you want values to change over time, we can just use a time function. So the basic difference is time is in seconds. So every 25 frames or 24 frames, the value will change by 1. And then frame is essentially just, this is the frame. So 1, 2, 3, 4. So to do it, in a very, very simple way, if instead of add ptnum, I just put in add frame. Okay. And just remember how it is typed here, right? So if I take a warp, and you'll notice that, with ptnum, everything is small, but with time, the T is capital, or with frame, the F is capital. So just, remember that. So you can just come in here and I can say add frame instead of add ptnum. So I can say add frame, put a semicolon at the end. And now what's going to happen is, like, per frame, you can see it starts to rotate. And then maybe you can do something more fancy. So I can do something like, let's do multiplied by at ptnum. And so what's happening is, like, they keep spinning too much because now each one is multiplying by the value, that of the point number. So you can do stuff like that, but this is where it becomes a little more interesting. So if I just keep it to ptnum, but then I come to the sort, and in the offset, like we are offsetting this, in the offset, if I put in add frame, and what you're going to get is, if I press play, this is what happens. Okay, like we're not playing it, we're actually playing it too fast. So switch on this button, which says real time toggle. And then if you play it, so you can get something like this. Now let's do something a little more interesting. Okay, so I can delete this and I'll switch this to, you can do something very nice called proximity to point, which essentially puts like a value in the center, and then the numbers kind of radiate outwards from that. So we put in proximity to point, and you'll notice, like, if I change that center around somewhere, it will shift. You can see the tiny little dot that moves along the grid. Now I also want to shift this, so I can take a second sort. Okay, so this one is proximity to point, and then I'll take another sort, and what I want to do is I just want to shift those points so I can animate them. So I can just come in here and I can just keep it to shift, and I can say add frame and press play, and that's what happens. If you want it to go outwards, we can do a negative, so I can just do a minus, and so you'll get this. If you want more points, just increase the grid points, like I can, if I make this something like, say, like that much, and yeah, let's make this even smaller. So let's make it about, what you can do is you can divide it by the total number of points. So the value will always be between 0 and 1. Okay, so I can just do at num pt. Okay. Again, just go into the warp node if you don't remember stuff, but there you go. So now what's going to happen is, as you press play, you'll notice that if you feel it's too slow, just multiply, like come into this, multiply it by 20. Okay, that will go faster. See, maybe 20 is too much. Let's try 10. And again, let's delete that. So yeah, so you can do, some pretty fancy stuff with very, very basic things. Like, we haven't really done anything complicated. Now let's take a look at a couple more attributes that allow you to modify, copies or points. So the first one is called scale, which is essentially a vector. Okay, so a p-scale is a uniform scaling value, and scale effectively allows you to modify just, one particular axis. Okay, so it's essentially non-uniform scale. So you can do X, Y, Z. Okay, so what you can do is, if I come in here and let's say if I just get rid of this, I'll do a control X, so it'll stay in memory. And what I can do is I can do at scale, and then we want to set a value for it for now. So I'll just do a set. So type in set and then take the bracket. And then let's say I want it 0.3 in X, or let's say 0.4 in X. And then 0.8 in Y, and then 0.3 in Z. Okay, and then if we click this, see, so what you've done is you've done like a non-uniform scale. So if I take this and I make it say 0.1, see, so you can flatten it like that. Okay, so where P scale was doing it for the whole thing, this is essentially you're just doing it for individual axis. Now, we have been seeing how to sort of modify points and how to randomize, scaling values and stuff like that. So what Houdini does, because this is something that you will do a lot, because if you're trying to do an environment, you want to randomize the scale and rotation of the trees or the grass or whatever, this is stuff that you'll do, a fair bit of times. So Houdini gives you a couple of ways by which you can just randomize these particular attributes. So there is one more attribute that gets used a fair bit, which is primarily for rotation. So I'm going to get rid of this. Like, let me get rid of the attribute create. Or actually, no, let's keep that. I'll get rid of the RT. And we can also, instead of using the copy, if you are just using the ready-made attributes, like if you're just using P scale and the new one we're going to use called ORIENT, which is for rotation, then you don't need the copy stamp. You can just use something called copy to points. And copy to points is sort of like you can modify existing values using these ready-made attributes. It's pretty straightforward. Okay, so what you can do is I can just connect this and then I'll connect that over here. You'll basically get the same result, okay, because we have P scale and all of that. And let me get rid of the scale as well over here. So we have this. Now the way it works is you get something called as, I'll get rid of this for now. You get something called as randomize. So you'll find something called attribute randomize. So you can plug that in, and default what it does is it generates a color value. And what any copy tool can do is if it finds color values on your points, it'll automatically transfer them to the copies. And the great thing about Houdini is that if you try to render this, it'll actually render the color. Okay, so if you just take a new floating panel and we render this, so I'll just pick up render view and hit render. See, so it'll automatically just, if I just zoom out a bit, it'll automatically just render those values. Okay, so that is really good. So when you want to sort of randomize, say, colors of your copies or anything like that, this is a very easy way to do it. But what I can do is, if I type in any of the existing names like P scale or ORIENT or scale, it will automatically randomize that value. So if I take P scale and see what you've gotten is it automatically just randomizes this. Now I think the sort is getting animated. So let's do one thing. Let's just bypass both of these. So we won't get any animation. What you can also do is if I don't bypass this, you can also randomize the scale. By default, it sets a value. So it sort of just overrides whatever is existing. But you can try to do something like you can do add value. So it's now adding, to that. Or I can do multiply. So you can multiply with the existing, value. So you can do this. Let's bypass this. Like I don't really want this right now. Yeah, and then I can also take, if I take ORIENT, okay, so I can just type in ORIENT here. Now, the one thing you need to do before I type in ORIENT is you need to set the dimension. The dimension is essentially, is it a float or is it a vector? So P scale is a float, so this should be at 1. Okay, and then the values down here is what your scaling values are. So minimum is like, let's say I want a minimum of 0.4 and a maximum of 0.8. So you can essentially, scale between that. Now, if I change this to ORIENT, ORIENT is what is called as a quaternion, which is essentially 4 values. It's a math concept. I don't understand it very well. But what you need to do is for it to start working, you need to adjust your dimensions to 4. And the minute you go to 4, you'll see this happening. So now it is randomizing, the rotation. And then if I only wanted, like keep the last one to 0 and 1, But if I only want to affect y-axis, I can take the x and z to be 0. See, so now you're only affecting the y-axis. Or then, and you can take multiple of these. So I can also take another randomize, and let's say this is randomize orient. And let's say this is randomize p-scale. So I can just take the p-scale and I can set the p-scale as well over here. See, so I have, both of those things. And you can also do like an overall multiplication, on top of it. And then maybe I also want to do some color, so I can take an attribute randomize. And then this is for color. So I can just say this is randomize color. Now, another way of generating color is that you can also take like an existing attribute and set a color based on that. Okay, so if I don't want to pick it up from here, but this is random color, what you can do is you'll get something called as a color node. Okay, so I can take a color node, and what I can do is I can take, like, let me just turn this off temporarily, the randomize p scale, and I have like, this is my, like, I'm generating a basic 0 to 1 value in p scale. And what I can do with the color is, you have different ways, like I can just give it a color, a flat color. But what I can do is I can come in here and I can say ramp from attribute. And it'll ask you what attribute, so I can put in p scale, and there you go. So what I can do now is I can actually set up, a color range for this. So I can just take, whatever colors I want. And then if I take that sort that we had here, like, let me just, if I pick up both of these, you'll actually see the color also change. See. So because as the p scale value changes, the p scale is driving the color. So you can actually do, stuff like that. So yeah, so you can do a whole bunch of stuff using, basic attributes and copies. Okay. Now let's take a look at one final thing. Before I'll go back to the original project that we had done. Okay, so what we had done in the previous one, where we had just taken that rock and I had done a basic scatter. So we're going to take a look at that again, and we'll just sort of modify it a bit more. But before that, we have one more thing to look at. So the final thing we want to look at is something called as mask. Okay, so masking is new to Houdini 18. It's essentially, they're taking some existing stuff that was a little more complex, and they've just built really simple, easy to use nodes out of it. So effectively what you can do is you can generate a mask based on a selection, or you can also generate a mask based on another object. Okay, so just to show you something very quickly, let's say I'll just duplicate this. I'm going to take this and do Control-C, Control-V. And if you want to disconnect it, just shake it. So it will just disconnect. And what I want to do is I just want to take a grid and connect that. So I'll get the same thing here. And I'll increase the number of copies and I'll scale this down. Yeah, we're still seeing the ghost happening. So let me just change that. Okay. So yeah, the template was still there. So just scale this down till we can see everything. Okay. So if you type in mask, you'll get these three things, which says mask from target, mask from geometry, mask along geometry. So we'll do the first two. Okay, so we'll do mask along geometry. What that does is, if I plug this in and if I make a selection, it generates an attribute called mask. And what it needs like a start point. So I can take a start point here, and let's say if I pick this as the start point, you'll notice that it generates a color based on those start points. And then you can generate a radius from here. And if I take a wrangle and I say at p scale is equal to at mask, because what is generated is an attribute called mask. Like if I click here, you'll see that it generated an attribute called mask. And then if I plug this in there into the copy, you'll see this. And so if I come back to the mask and I make changes, see. So as I increase the radius, you can make stuff like this. If I make adjustments to this guy, So you can do stuff like that. So you can very easily just, build slightly complicated effects this way. Now here what we can do is the group stuff that we had done last time, we can use something like that. So what I can do is let me just take a group and I want to select, we'll call it A. Okay, and I want to select the point and I want to select 0. Okay, so 0 should be there. See, there's 0. Okay, this particular point, that's 0. And then I'm going to take a group expand. So I'll plug in a group expand and we'll say output group is on and we want A. And now we come into mask and instead of selecting like start points, I'll just type in A. So you'll get something over there. So this is fine. Okay, but now you can do something interesting. So if I come into the group expand and I start to increase the steps, you're essentially expanding that. And what I can do is if I put in say at frame, then you should get, something like this. See, it will just allow you to fill up everything very, very quickly. So again, if I come in here and then if I do the sort thing, and if I take the sort and say like proximity to point, so the sort comes in the center, and now using the group expand, I can very easily just, have the whole thing expand out. So you can then come back here and then adjust the radius so it's slightly smaller and just, have it expand. So this is a really nice way to, adjust stuff. Now, again, you can start doing more interesting stuff with this, which is I can come down here and maybe then you can multiply it with, I can take a randomize. So I can say attribute randomize. I want to randomize p scale and I want to multiply it with the existing. So what you'll get is you'll get something like this. See. Okay. Now, along with this, you also get another thing called noise. So you'll get something called attribute noise, which generates a noise map. Okay, so effectively like you can see it here, like see it generated a noise. But what I want to do is I want to affect p scale. So we'll take p scale and we want to generate, because p scale is a float value, we want to generate a 1D and it should allow me to see this. See, so you have like a noise map here. And what you can do is you have like different options. You can generate the element scale, which is the size of the noise. And then you can also, define roughness. And we can also try to make it multiplicative. So it's multiplying with the existing stuff. See, so you can get a noise map instead of having just a. So you can do some pretty, nice things with this. So this is mask along geometry. But what you can also do is if you have, let's say I want an object to move along this and that will make, that will cause an effect on the copies. I can do something else. So I can take a sphere and let's make it polygon and I can do a mask from geometry. And then if I plug these two things together and I can just let's just animate this, right? So I'll take a transform and I can move it here and we'll do alt click and come a little further and just move it to the other side. Okay. And what that should do is you'll get a mask moving like this. And then again, let's just sort of, modify it a bit like that and just increase the radius. And what I can do is I can just plug this in here because this is generating the mask and that is also generating a mask. If I come down here, you'll see this. See, but now you can do something a little more fancy with this, which is if instead of this, I take a text, right? So if I take in Houdini, text is called font. So if I just type in font, and by default, what it does is it allows you to just it generates like a frame value and it's just doing this, right? It's doing it's just running a counter. But what I can do is I can take a poly extrude and I'll extrude this. And extrude doesn't generate a back by default, so you need to turn that on. So what you do is you just come down here and you say output back. And let's change the font type to something a little better. So I'll take a Arial black, so which is a much more thicker sort of font value. And also we need to lie it flat on the ground. So let's take a transform and I'll plug this in and I'll rotate it flat to the ground. So we'll do like -90 and then just move it down a bit. Okay. And so instead of this, if I plug this in and I go back to my copy, so what you should get is you'll see the value change over there, but we don't have enough points. So what you want to do is you just want to come down to the P scale and let's make it about say 300 by 300. So you'll see enough. Yeah, okay, I think we need to go, the box needs to be smaller. Yeah, and maybe get rid of the noise. I don't know, the noise is probably not a good idea. But yeah, you can do, it needs to be a little more refined than this, but you can do stuff like this. Okay, let's make it 20 by 20. No, hold on. Let's make it 100 by 100. We need the font to be bigger, like a lot bigger. So let's do one thing. Let's just keep the $F. So you'll just have the text, nothing else. We'll take the mask along geometry and just keep it straight like that. Adjust the radius and then take the font and make it big. Yeah, there we go. That's better. Perfect. See. So now you can essentially see this change. Now I can bring back the attribute noise. So there you go. So yeah, so you can do, a whole bunch of stuff with this by just having some basic attributes and then using masking and the noise maps and the randomized values and just generate, a whole bunch of stuff with it. All right, so as a final thing before we close this, let's go back to that little rock that we had made with, the few things on top. So what I can do is I copied and pasted that into this file. So this is where we were. So what I want to do is I want to firstly add like a bend to this line. So let's make it slightly longer. So I want to add a bend to this line and maybe, copy something else to the top. And then let's use all the stuff that we had done. So I can also add like a little bit of random rotation and scaling to this. So the first thing is let's just come down here and we'll add a bend. Okay, so I can just take this line. Okay, so let's just take a bend. So I'll just type in bend and we'll add it in the middle. And the first thing I want to do is I want to adjust the capture direction because right now it's capturing in like the Z axis. So let's change that here to the Y axis. And then I can just bend it. So I'll bend it like this. Okay, you also want to adjust the capture length and make it the length of the line. So we can just do that here. So I can just right click here, do copy parameter, come to the bend and paste relative reference in the capture length. So this is good. This is fine. And now if we come down here to copy, you have this thing. But what I want to do is there is a small issue, right? Like if you notice the sphere is straight, like it's not really bending along the curve, right? Like if I come back to the curve and I make some adjustments, you'll see the sphere remains the way it is. And it'll be more apparent if I take a box. So if I just take a box and I drop that in over here and let's make it small. So you'll notice the box doesn't bend. And what I want is I want it to bend along the curve. So what I can do instead is let's just come down here and you get a tool called orientation along curve, which what it does is it generates like normals along the curve and it allows you to sort of orient the copies along a curve. So if I just drop this in the middle, it will repair it. See, there you go. Okay, so it's pretty straightforward. So now if I bend it, you'll see like it sort of, sticks to that. So it's pretty easy to do this. So we have our basic thing done. Now you're getting an error here because what's happening is that when you generate orientation, it's essentially generating something called a normal. And the problem is the box doesn't have normals. Okay, so if there is a mismatch in the things coming into the merge, especially like if it's normals, then the objects that don't have normals, they turn black. Now you have two options to this. One is you generate normals for the box, but then we'll also have to generate normals for the sphere, because when we do this merge, it will again cause problems. So what I can do instead is I can just quickly delete the normals. Okay, so I can come into this point and you have something called attribute delete. So I can just take the attribute delete and come into point attributes and I can delete the normal and see. So now it's fine. Let's also give it a polywire to give it some thickness. Okay, that's way too much. So just a little bit. Yeah, okay. So what we get is we're back here. So we want to do a few things. Firstly, as I said, let's randomize the rotation and randomize the scale. So I can come down here to these, like these scatter points that we have. And I can just take for the scaling, let's take a noise. So I'll just take a noise here. We'll say attribute noise. And by default, it goes to color. But what I can again do with the color is, let's say if I want to give it, some kind of custom coloring, I can set this to 1D and let's just create a custom attribute, right? So we'll take a wrangle. So everything that we've done so far, I'm just, sort of using all of that. So let's just say F at C, okay, and that's 0. And here in the attribute noise, I'm going to use C. So we have this, okay, so you essentially just generated an attribute called C, which has some noise values in there. And I can just take a color node and I can feed C into that. So I can just say ram from attribute and plug in C. See, so there you go. That's what you get. And then I can give it some color. So the point with this is, rather than having a noise map controlling the color, I can just, build some color on my own. Yeah, and then maybe, so if I look at the plant seed, you'll get something like this, which looks a lot more elegant. Okay, so this is good. Now let's randomize this. So we'll again take another noise map, attribute noise. I'll drop it in the middle and we'll call it P scale. And again, keep this to 1D and this will be P scale. And there you go. And then we can just take the amplitude and maybe make it a little bit bigger. So this looks fine. And then we can also take a randomize. Okay, so for the orient, so let's take a randomize. And I can keep this to 4 and call this orient. Yeah, now by default it will randomize in all directions. We only want it in Y. So take both of these to 0. And there you go. So what you get is like this, and instead of 0 to 1, make it -1 to 1. So it will sort of randomize in all directions. And if you don't want it to bend too much, we can probably just lower the bend. So let's just keep it about this. And then I can come to, let's increase the scatter amount, because I can come to the scatter. The first thing is it by default gets a uniform spacing between them. So let's lower that to make it look a little more randomized. Okay, so the scale by radius, you can lower it. And then let's increase the density scale to a fairly big number. And there you go. So all that basic stuff that we did so far. Okay, let's reverse the color. Okay, so we'll flip this. Let's make this here and yeah. So the smaller ones are green and maybe these are yellow and then it turns red. Yeah, I think that looks nice. Yeah, see, there you go. That looks good. Yeah, so that's basically it. So this is not everything as far as attributes is concerned. In the next lesson, we'll be taking a look at, a few more things dealing with attributes and a few more extended stuff dealing with Vex, which is the programming language that gets used in Houdini. We have done a little bit of vex already, because whenever you type something in a wrangle, this is technically vex. So we'll take a look at a few more functions and also how to build a few more controls for our attributes. But yeah, so this is essentially how you can use attributes to control copies and control various attributes and generate, more complex stuff with that. Yeah, so that's essentially it, and keep watching.